the information for Chapter 8, the in-class homework for Chapter 8. And let me get to the top of the page here so we can see it all. For this one, it's cost relationships. And you can see that for this one, we got Chimney Sweep provides cleaning services for residential chimneys and fireplaces. The cleaning service requires $35 variable cost for cleaning materials. The fixed cost of labor of the company's truck and administrative support is $165 per year. The sweep averages 100 service calls per month. So the question then becomes, what is the average cost per cleaning service? And you can see here that what they gave us, the variable cost is 35, the fixed cost is 165, the service calls are 100 per month, or 1200 per year. And so what we can do then is use that information to compute the average cost per call. Now this, I notice it says computer down there, but it actually is per call. So the number of cleaning services, and the formula is right here. Y equals A plus B times N. And so we've got $165,000 fixed cost plus $35 variable cost per unit, and so we're solving for N. And so the total annual cost is $1,200, so we put in the 1,200, and so we get 165 plus 35 times 1,200 for a total cost of 207. We take that 207 divided by 1,200 calls per year, we get a cost per unit of $172.50. The next one is 35, and for 35 we've got the high-low method here. And for Horton Manufacturing, it says that they produce blinds and other window treatments for residential homes and offices. The owner is concerned about the maintenance cost for the production machinery, as maintenance costs for the previous fiscal year were higher than expected. The owner has asked you to assist in estimating future maintenance costs to better predict the firm's profitability. Together, you've determined that the best cost driver for maintenance cost is machine hours. The data from the previous fiscal year for maintenance expense and machine hours is as follows. And you can see what those numbers are right there. And so we've got expense and hours for the full 12 months of the year. And so for question 1, what's the cost equation for maintenance cost per unit doing the high-low method? That's really the only method we're going to worry about, is the high-low method. And so based on the data here, you can see here that we've picked C20, which is month 6, June of 3005. The corresponding hours for June are 1,880. The low month is 2,570, which is the month of October, and the low number there is 1,410. And so the difference then is 435 and 470. And then my constant, you can see how I got my constant, is I took the expense minus the hours, and I'm sorry, the expense is C37 minus C41, which is the basically my formula down here, times D37, which is the hours. So this number right here, and basically this is dividing the change in expense divided by the change per hour, gives me my slope. And then with that number here, my maintenance cost transaction or equation is the 1,265 plus the 0.925 gives me the number of machine hours. And really it was that simple. So the model then, or the formula, is just that right there. And then if you were to slope it, you could see that this is what shows up right here. And it shows that point number 12 is an outlier. And you can see that it stands over here by itself. It's not in line with the other ones. So that was one thing to keep in mind too. If I come back to the data up here, it's not apparent that that's an outlier by looking at all the numbers, but if you graph it, it does show up as an outlier. And I'm not requiring this method, the MAPE method at all in class, but you can look at that, and I'll post this for you to take a look at if you'd like to on your own. But I'm not requiring that we do this in class. So that was it for Chapter 8.